Okay, this is Jerry Dunifer, and he's going to give a talk about his tour of telescopes in Chile. Please welcome Jerry.
Okay, thank you, Sandra. Can everybody hear me? Okay, so I'm going to be talking about a tour I took 2 years ago down in Chile back in 2017. So we can get the lights down. So this is a tour that was arranged by Sky and Telescope magazine. And the main purpose was to go down and see some of the major telescope observatories down there. So I'm a retired professor, a professor emeritus from Wayne State University in the Department of Physics and Astronomy. I've been retired now for 13 years. I highly recommend retirement. And I was on the faculty there for 35 years. So this picture here on the front is part of the ALMA observatory, which I'll be talking about in a little detail towards the end of the talk. So this tour went for about 10 days. I think we had about 30 people on the tour, and we saw a number of things. We spent the first day in the city of Santiago, which is the capital, has about 6.3 million people who live there. And then we went to an observatory, Cerro Calan, which is connected to the university and is used primarily for teaching purposes. And then we went to 4 major research observatories, La Silla, Cerro Tololo, Gemini South, and ALMA. ALMA being the Atacama Large Millimeter and Submillimeter Array. And even though we didn't visit them, we were very close, within less than a mile of 2 other observatories. There was SOAR, Southern Observatory for Astrophysical Research, and the LSST, now under construction, as it was then, the Large Synoptic Survey Telescope. And as part of a tour, we got to visit the highest geyser field in the world and a geological arrangement of stone and sand called Valley of the Moon. Okay, I'm disconnected here. Okay, thank you. So the day I left, I took this picture of my neighbor's home across the street. And you can see there's snow on the ground. It's just towards the end of winter. And I'm going to be going down to Chile in the southern hemisphere. So the seasons are switched, so it's going to be towards the end of summer when I get down there in about 24 hours. So we flew all night long, and I'm sitting on the left side of the plane, and I'm looking out to the east, and I can see the Sierra Mountain Range, which is over here. And there's one peak in particular, which is quite a bit higher than the others. This is Aconcagua. It is the highest mountain in South America. It is the highest mountain in the southern hemisphere. It is the highest mountain in the western hemisphere. At the summit, you are 22,800 feet above sea level. If you want to compare that to Mount Everest, it's still about 6,000 feet shorter than Mount Everest is. So we've now landed and we're in Santiago, where we spend a day. And this is our local tour guide, which takes us around, mostly a walking tour to see different parts of the city. And I'll show you just a few pictures of the city. It's a very modern city. Number of the people are astronomers or amateur astronomers, and we saw a lot of t-shirts which are being worn, which were astronomy related. So this particular person is from Arizona, and on the back of his t-shirt we have the 2009 Messier Marathon that he participated in. And here's another t-shirt, and I think you can easily read what's down here, but if you look carefully at the stars up here, they spell stars over K-A-T-A-H, Katahdin. Stars over Katahdin. Does anybody know what Katahdin is? That is correct. Very good. You get an A for the night. Katahdin, Mount Katahdin. That's right. The terminus of the northern terminus of the Appalachian Trail is there at Mount Katahdin, and that is what this t-shirt is all about. So we walk. Yes.
When you were in Santiago, did you think it was a safe place to be?
Certainly, yeah. As far as I could see. Certainly in the group, there was no problem in the group.
Just because you were in a group, did you think the place was safe?
It looked safe. I saw nothing that looked dangerous to me. Probably safer than Detroit. So anyway, down in the center of the city, we walked through a park. So here's a few pictures taken from the park. You will notice that there's no snow on the ground here, and people are out in their short sleeves. So it's a fairly warm day. A church on the edge of the park, and a picture taken inside the church. Okay, so first observatory we went to is the National Astronomy Observatory of Chile, Cerro Calan. It's owned and operated by the University of Chile Department of Astronomy. It was established in 1962, located a little east, but on the outskirts of Santiago, at about 2,800 feet above sea level, and has a variety of telescopes. But because of the serious light pollution problem and general haze in the air, it's mainly used for teaching purposes rather than too much research. So they got a 47-inch millimeter wave Cassegrain reflector, an 18-inch Cassegrain reflector made by Go2, Japanese company. They had two 11-inch refractors, a 4-inch astrolabe. So this is a picture from the air looking down on the hill where the observatory is located. It's going to take me a while to get this. Here we go. So this is the major observatory dome on the hill, and you'll see that in another couple of slides from the ground. So here I'm looking in the headquarters, so you see a number of things. You see the name of the institute on the glass door. You can look through the glass door and see the furniture inside. You can look at the reflection of the glass door and see what's behind me. And finally, you can see my silhouette here taking the picture. So again, Cerro Calan Observatorio Astronómico Nacional. So here's that observatory dome again, seen from the ground. And another dome. And I'll point out this individual. This is a retired vascular surgeon, Dr. Ismar Centora, who lives in Phoenix. He and I have done quite a bit of traveling together to see telescopes around the world. So he was with me on this trip. So this is the director of the observatory. This is Dr. Patricio Rojo, who showed us around. We had a solar telescope. He got out so we could look at the sun briefly. You notice that the telescope was not pointed very high into the sky. So this is getting to be late in the evening. One of the 11-inch refractors. one of the other telescopes. This is our 18-inch go-to telescope. And this is looking from the observatory grounds down into the center of the city. So we stayed there until evening, until dark, and they served us dinner, a very fine dinner, the best meal we probably had on the whole trip. But as you can see, there's a lot of light from the city. Okay, now we've traveled 300 miles north by bus, and we're in the city of La Serena. This has about 200,000 population. And if you're in La Serena on July 2nd of this year, you will see a total eclipse of the sun. That's right. So this is one good place to be on that date. So a few pictures inside the city. Also, it's a nice, neat, clean-looking city. This is the Central Park. Yeah. Okay, so we stay overnight in La Serena, and the next day we head off for the first major research observatory. So this is our bus, and you can see the Sky and Telescope logo here. So there were a few empty seats, so again about 30 of us, there was a lot of room on the bus. And so we're driving about 100 miles to the northeast, to La Silla, first major observatory. And as we head into the foothills of the Sierras, you can see the terrain changes. It's looking rather barren, rather brown. So the La Silla Observatory is operated by the Europeans, the European Southern Observatory. It's at an altitude of about 7,900 feet above sea level. And I'll mention three of they have a number of telescopes, but I'll mention three. The two big ones are 3.6 meters in diameter. And the first one is the ESO telescope with HARPS. HARPS is the High Accuracy Radio Velocity Planet Searcher. So this has been very successful in finding exoplanets, planets going around other stars. And what it does is it monitors the radial velocity of the star, its motion towards us and away from us. So as a planet might be orbiting around that star, the planet's gravity pulls the star back and forth a little bit, and that can be detected by carefully looking at some of the spectral lines and seeing how they shift back and forth due to the Doppler effect. Another one is the 3.6 meter New Technology Telescope, where they try out new technologies which can be incorporated later at other observatories or in other telescopes. A much smaller telescope, but now rather famous, is one which is 0.6 meters in diameter, called TRAPPIST, standing for Transiting Planets and Planetesimals Small Telescope. So this is operated remotely by Belgians in an observatory in Geneva, and it is looking for, again, exoplanets going around other stars, but they're looking for situations in which the planet may pass in front of the star, cutting off a little bit of light coming from the star, looking at a transit. And
for those of you who don't know, the amount of light drops, if it's like putting the point of the pin in front of the high beam of the truck, the amount of light changes. It's probably 0.000001% of light all it changes, and they can detect that.
well, that depends on the size of the planet and the size of the star.
Minute, this amount.
Yeah, but yeah, that's a very small change in general. But this particular telescope is most famous because it discovered TRAPPIST-1, which is a rather cool red dwarf star, and they discovered 7 terrestrial planets which are in orbit around that star, 3 of which are in the habitable zone.
Did they find another one on that one recently? Don't they have
There may be. I'm not aware of the eighth, but for some time there I've been aware of 7. 3 of them in the habitable zone, which means the temperatures are such that water can be liquid on the surface. And that gives the possibility of life as we know it.
The reason why I remember it is we were talking about it last year. That it was the first solar system they found that has the same number of planets orbiting as we do.
Oh, excellent. Okay.
That's why it clicked in my mind. It was a big
Okay.
on that.
Okay, I guess we can add one more then. 8 known planets going around that star. Okay, so here we are. We're going towards Lassie Observatory. We're out really in the desert now, very dry and barren. And if you have very good eyesight and you look right there, the little bump on top of this hill, that's where we're going. That's the larger observatory dome. So now we're a little bit closer, and you can see a lot of little bumps up there. There are a number of observation domes. Biggest dome, which is associated with the exoplanet finder, is this one right here. And this is the hill the bus is lumbering up. And we finally get into the observatory grounds. So again, the telescope, this is the big one that's been very successful in finding exoplanets. And a little bit closer view. You'll notice that outside there is a walkway, and they let us go out on the walkway, and I'll show you a few pictures that I took from the walkway. So this is inside. This is the telescope, 3.6 meter telescope. So the primary mirror is down here, 3.6 meters in diameter. Secondary mirror is up here. And who can tell me what kind of mount this is? An RC? That's not what I'm looking for.
Expensive.
Expensive. Yeah, expensive, right. This is an equatorial mount. Equatorial mount. Yeah, because this is the polar axis here. That's a line parallel to the Earth's axis of rotation. So as the Earth rotates, the telescope is rotated in the opposite direction about the polar axis at the same rate to keep the telescope pointing at the same direction in the sky.
Yes.
A cannon? Well, no, I don't think. I think they use more. No, this is used almost exclusively with HARPS, which is an ultra-sensitive spectrometer looking for small shifts in the spectral lines. They wouldn't let us see HARPS because it's in a temperature-controlled room. It's very sensitive, very delicate. We're not allowed to go anywhere near it. Okay, now I've gone up to that walkway and I'm outside walking around looking so I can see a number of the other telescope domes. And one we're going to visit shortly is this one right here, which is a new technology telescope, the NTT telescope. Okay, looking off along the foothills here, the Sierras, again, very, very dry, very barren. And this again is Dr. Centaura. Okay, so we're through with the first telescope. We've now gone over to the NTT telescope, and we're looking back towards that first telescope. The new technology telescope. So this is our local guide, one of the astronomers who works there, and is describing this particular telescope to us. So this is the primary mirror here. Just behind him, 3.6 meters in diameter. Now they've developed a lot of technology here, including one in which they can control the shape of the mirror, called active optics, in which they have actuators below thin mirrors, which are pushing up or pulling down to control very precisely the shape of the mirror. And this is the top of the mirror, the mirrored surface. Another view of the mirrored surface. And one final view, you can see some fans on the side which can blow air across the mirror to help control its temperature. And stepping back a bit, we can again see the same mirror down here and the secondary mirror, which is up there. And a couple more views just looking around at the surrounding countryside. And now going to the small telescopes. TRAPPIST is right here. So this is a just a 0.6 meter telescope operated remotely and has discovered several exoplanet systems by looking at transits of the planets across the disk of the star. Okay, now in the control room, there's nobody there working because it's daytime. Astronomers are all asleep. This is for the telescope operator for the 3.6 meter telescope that works with harps. Operator sits there. And one of the display monitors. And for the NTT telescope, the operator sits in this chair. Looks like he's been throwing some papers around. Yeah, I think he can. Looks like he is. Oh, well, let's hope not.
He's wondering who looked into the camera.
So another display monitor. So anyway, we see the humidity is 55%, and the temperature at that time, that day, is 14.5 degrees Celsius. It's 58 degrees Fahrenheit. So reasonably comfortable with a light jacket. Okay, so that's our tour at Lucia. We're now on our way to the city of Vicuña. And you can see this is rather desert-like country. There's a lot of cactus and things like that in areas where anything grows. And although things look rather barren down in the valleys where they can get water in from the melting snow up in the Sierras, they have some orchards and vineyards and other crops which they grow. And now we're in Vicuña, city of 25,000, and this is the mayor of Vicuña. The mayor has a pet project. He wants to make Vicuña the astronomical capital of the world. So when he heard that Sky and Telescope was in town, he insisted that we come and pay him a visit. We found out about this, I think about 9 o'clock at night when we were getting ready to go to bed because we were tired. But he insisted that we come because he wanted to promote his idea to make his city astronomical capital of the world. So he got up and gave some speeches and handed out a few gifts. This is one of the gifts down here. This is our tour guide. This is Kelly Beatty, who is one of the senior editors at Sky and Telescope magazine. So he is our general tour guide for the whole trip. This other person, I don't remember his name, he's a member of our group, and his advantage is that he speaks both English and Spanish. So he served as a translator, because the mayor speaks no English and Kelly speaks no Spanish. So he's our translator, and he did a fine job on the spur of the moment. Vicuña. Okay, another picture of our mayor. So now the next morning we're going to visit Cerro Tololo Inter-American Observatory. This is a U.S. observatory. It's managed by NAOA, the National Optical Astronomy Observatory. It's about 50 miles to the east of La Serena at an altitude of about 7,200 feet above sea level. And the regular observations began there back in 1965. Their major telescope is the Blanco telescope, 4 meters in diameter. Now, back in the year 2011, the Nobel Prize in Physics was awarded for the discovery that the expansion of the universe is not slowing down, as everybody suspected, but is actually expanding. It's going faster and faster. We don't have a good explanation. The word we use is dark energy, but it's not at all well understood. But that discovery resulted in the Nobel Prize, and the data for that discovery, a lot of it was taken at this site with the Blanco telescope. 2 different research groups, one centered on the West Coast, the other on the East Coast. And the Nobel Prize was divided between them. Okay, so now we're driving from Vicuña up towards this observatory. You can see it up here on the hill. And as we get closer, you can see a bit more, but the big dome is for the Blanco telescopes, and there are some smaller ones. So first of all, we come to a T-junction, where we can turn only left or right. So if we go to the left, we're going to end up at Cerro Tololo, 3 miles away. If we turn to the right, we're going to end up at Cerro Pachon, where there are in fact 3 observatories, one of which is the LSST, which is under construction. But first we're going to go left. So now we're getting close to Cerro Tololo. Again, the big dome is the Blanco telescope. So we're up here, the bus is parked, we're out. We can look around a bit. So again, the surroundings are very dry and barren. Here we're looking to the south towards Cerro Pachon, where the other 3 observatories are. So this is a ridge over here. This is about 1,700 feet higher in elevation than we're standing when this picture was taken. So that's a close-up of Cerro Pachon. So this is Gemini South. This is the one that we're going to visit in detail. This is SOAR, and this is the LSST under construction. So this is Kelly Beatty taking a picture of our mascot, which is posed here on his tripod. There he is. He was with us for the whole trip. So this is one of the smaller telescopes. I think it was about 2 meters in diameter. And they tipped the telescope over and removed the shutter off the mirror so we could see the mirror or see reflections in the mirror. And this was a local guide there who told us a bit about the telescopes. If you look at his hat, can you read what's on his hat? Michigan State. So he's obviously got some connection to Michigan State University. In fact, Michigan State uses at least 2 or 3 different telescopes in this region for the research that they do. This is part of our group listening to him. So this is the big telescope. This is the Blanco telescope, which is tipped over on its side because they're doing some maintenance work while we are there. There's another view. The telescope is so big and the dome is sufficiently small, it's hard to get very far away from it and take a picture showing the whole telescope at one time. So we can just get bits and pieces of the telescope.
Is that an equatorial drawing?
No, I don't think it's an equatorial mount. Pretty sure it's not. So I got a picture of one of the technicians doing some work, and when he saw me taking the picture, he gave me this gesture. I'm not quite sure what that means in Spanish. I didn't ask.
If he shows you this side of the fingers, it's good.
Mm-hmm. So what's he doing? Okay, so after our tour at Cerro Tololo, we come back past that T-junction again. And so there's the proof that I was there. And again, this is Cerro Pachon, where we're going next with the 3 observatories up there. But this is a nice area with a nice view. So they have 3 sighting tubes lined up with the 3 observatories, which one can look through. And there's also this plaque, which is there. I don't know if you can read it or not, where it says, "This beautiful view is dedicated in honor of Dr. Sidney Wolfe, whose vision and leadership as director of NOAO, director of Gemini, and president of the LSST Corporation, important in the establishment of the facilities you see here on Cerro Pachon." Sidney Wolfe is an American astrophysicist. She is the first woman astronomer to head a major observatories in our country, and she was responsible for the establishment of 6 total major observatories around the U.S. and around the world. She also she was a co-author in a textbook, which we use in our introductory astronomy course at Wayne State for a few years. So a couple more pictures in this area. There's a cactus growing there. Another view of the cactus, and looking up again at the 3 observatory sites. This is Craig Nelson from Portland, Oregon. He and I are getting together probably in another couple months or so. We're going to get a tour of LIGO Hanford, the gravitational wave antenna, the Washington State component. So we're going to go up to Gemini South. Again, on Cerro Pachon. In a straight line, it's about 6 miles from Cerro Tololo, where we had been previously, 8,900 feet above sea level. Fairly large mirror, 8.2 meters in diameter, and it has a twin, Gemini the twins. So the twin, Gemini North, is on the big island of Hawaii, on Mauna Kea, at 13,800 feet above sea level. I've been up there a couple times. So it studies everything: the solar system, exoplanets, formation, the evolution, the structure and dynamics of galaxies, black holes, distant quasars, structure of the universe on the largest scales. So practically everything except maybe the moon. So adjacent is SOAR, which has a 4.1 meter mirror, and the LSST, which is what was under construction, is still under construction today. It will have an 8.4 meter diameter mirror. So now on the bus ride up, we can look up and see the 3 observatories. And now we're getting relatively close to the LSST site. And here we are at Gemini. So that's the dome that holds the 8.2 meter telescope. The one on the island of Hawaii looks exactly the same. Just looking at the dome by itself, you wouldn't know whether you were in Chile or in Hawaii. So about a quarter mile away is SOAR, 4.1 meter diameter mirror. And there's a bit of a close-up. About 80% of the measurements made here are made remotely. And Michigan State University is one of the remote users of this telescope. And that is the end of the first half. So, can you switch me over to part 2? And while we're making the switch, are there any other questions?
What is the latitude of this general area?
It's, let me think, it's where we are here, 700 miles. Where we are here is about 40 degrees south latitude. Yeah, that's right. 40 degrees south latitude here. Okay, any other questions before?
What type of precipitation they get for the clear nights?
Yeah, they have a lot of clear nights. They get relatively little precipitation. There's relatively little light pollution, so this is a very good site for observing. The air is relatively dry, which is good for looking at the near infrared, which is absorbed by water vapor quite strongly.
Probably be more exposed to snow there when it makes rain.
They probably get a little slow right here. Look, as we get up towards Alma, we're going to be in the Atacama Desert, where it's exceptionally dry. Okay, so second half of my presentation. So we're here in Gemini. I'm looking back towards Cerro Tololo, where we've been previously. And here's the Blanco telescope there. And you can see the road that we took. So this is the road that we took to get up here. It's 6 miles away in a straight line and 12 miles by road. And just looking a little, zooming in a little bit more on Cerro Tololo. So now we're in the dome, and we can immediately see what the date is. So this is Wednesday, March the 22nd. So it's now definitely springtime in the northern hemisphere and fall in the southern hemisphere. And I see the local time here in Chile is what, 2:38 in the afternoon, and Hawaii is 7 hours earlier, which is 7:38. So here's our telescope, 8.2 meters in diameter. This is an alt-azimuthal mount. So the primary mirror is in here. Secondary mirror is up there. And everything rotates. This floor area you see here rotates, carrying the telescope with it. So again, the problem we have is it's so big and we can't get very far away, and we can only see small pieces. Here they've tipped the telescope over, and you can see the 8.2 meter mirror, except it's covered up by the shutters here. That is where the mirror is, right in there. Okay, so now we're leaving, and just looking off half mile away or so is the LSST, more of a close-up. So this is the Large Synoptic Survey Telescope. When completed, it'll have a mirror which is 8.4 meters in diameter, and it's set up to be a survey telescope covering very quickly large areas of the sky. It'll be able to see 10 square degrees, which is the equivalent of 40 full moons packed side by side. It will take 800 pictures per night, and will be able to cover the entire sky visible from this site twice in 1 week. And so they're expecting an enormous amount of data coming in. The camera has 3.6 gigapixels, 3,600 megapixels. And of course, that's going to produce just a fantastic amount of data, which will have to be analyzed. So they're going to have some very busy supercomputers at work. Yes?
Do they do long-term exposure when they're scanning the sky?
I doubt that they would do it here. They're interested in covering the whole sky and looking for changes that might occur over a few days. So
No, the images will be too short. Okay, so images are just so short, I'm going with their quick shot codes. Series.
yeah, well, they're going to do 800. Yeah, typically 800 pictures in a night. Okay, so now we're going to take a little break, and so we're going down to where they produce a brew, which is known as Pisco, and the name of the company is Capel, and this is made from grapes, They basically go through the process of converting the grapes into wine, and then they distill the wine to increase the alcohol content. So I think this is the percentage of alcohol. I think this is 40%, 43% alcohol. I, in general, don't like alcoholic drinks, but they serve us something called pisco sours. I think I could grow to like those. They're not bad. Much better than I was expecting. And here's our mascot again, who's showing up. So they took us on a nice tour through the facility, showing us the equipment that they use, where they age the wine. And these are the grapes that they use. And we sampled the grapes. They tasted quite fine. And the most attractive part was the tasting room. So we all got to sample some of the product. And then we got in an airplane and we flew 700 miles to the north into the center of the Atacama Desert. And we headed east going towards San Pedro de Atacama, which is we're going to be based for a couple days, 2-3 days. We visit Alma. So this is now quite dry. There are places in the Atacama Desert where there has been no precipitation for more than a century. That's how dry it is in certain places. So this is a wind farm that we drive through on the way. And we stop a couple times just to get out and stretch our legs. There is a little vegetation in the area, but not a lot. There are clouds. Okay, I will tell you about this mountain in another few slides. I'll tell you about this volcanic peak. It is beautiful. This almost looks like mud. That is not mud. Things are very dry. It's desert sand. And the white stuff is not snow. Those are salts. And finally, we arrive here, San Pedro de Atacama. So I just noticed that this is Craig Nelson. He and I are getting together to go to LIGO Hanford soon. So this city is about 3,900 people. It's very flat around the area, but we're still at an elevation of 7,900 feet above sea level. So quite high. And show you a little bit of the town. Astronomy is very important here because of Alma. And so they have tours, astronomical tours every night where they take you out and show you the stars and so forth. And so I saw probably a dozen different shops offering their astronomical tours. And they will also take you on tours of volcanoes. Volcano expeditions. And they have some volcanoes over here and the height of the volcano. And so that cone we were looking at earlier is this one right here, Lycankabur. Lycankabur, the summit's at 5,917 feet, meters above sea level. So a little bit more of the city. Most of the streets are not paved. We encountered some pretty good restaurants there. Here's one of them. And another shop advertising tours of the sky. And another one. Okay, so now we're on our way to Alma, which is only about 30 miles away. And as we drive, we're getting closer to this peak, Lycankabur. The summit is at 19,400 feet above sea level. If you think about the mountains in the U.S., the highest one outside of Alaska is Mount Whitney in California, 14,500 feet above sea level. So this is just about 5,000 feet higher than that. So these are very high volcanoes indeed. So ALMA. The Atacama Large Millimeter and Submillimeter Array. It's operated by the U.S. National Science Foundation, European Southern Observatory, Canada, Japan, Taiwan, Korea, Chile. A number of different countries make use of it. It's an array of 66 telescopes, which range from 39 feet in diameter down to 23 feet in diameter. And it's located up on the Chattanantur Plateau, 16,500 feet altitude. The air is so thin up there, they won't take us up to see it, because people who are acclimatized to our elevations, sea level or a few hundred or a few thousand feet above sea level, when you take them up to 16,500 feet, they tend to die. They get hypoxia, which can be lethal. They can die, so they won't take us up. If you are taken up, you have to be provided with supplemental oxygen. So we're 700 miles now north of La Serena. We're now on the edge of the Atacama Desert. This is the most expensive ground-based telescope in the world. $1.4 billion went into it. So it studies wavelengths from 9.6 down to 0.3 millimeters. If you prefer frequencies, this is 31 up to 1,000 gigahertz. So when I was doing research down at Wayne State, I made use of millimeter waves. And I operated 80 gigahertz and 120 gigahertz. So I'm rather familiar with frequencies in this range. This type of electromagnetic radiation is strongly absorbed by water vapor. And so they require a location which is very, very dry, which is why it's located here. Spatial resolution. These 66 telescopes together are all interconnected and operate as just one giant telescope up to 16 kilometers in diameter. And the resolution it has is 10 milliarc seconds. So as you know, 1 degree is normally pretty small. That's divided into 60 minutes of arc. Each minute of arc is 60 seconds of arc. And this now can resolve angular separations down to 1/100th of 1 second of arc. It's 10 times better than the Very Large Array in New Mexico. It's 5 times better than the Hubble telescope. Yes? I'm not aware that they're planning to expand it right now, but they may well in the future. They're getting very good data from it. And if they think they need more resolution, they could expand it out further. This is the largest radio telescope in the world. The detectors of the radiation operate at 4 kelvins, 4 degrees above absolute zero. Arecibo is a single dish. So this is a large number of dishes interconnected to function as a single dish whose diameter is equal to the separation, maximum separation between the dishes. So this has been operational since March of 2013. Where they took us was not up on the plateau where we would die. We were at the Operation Support Facility, 9,500 feet above sea level. So the individual antennas are about 115 tons, and they can be moved around to change the effective focal length of this instrument. No, that's not what I want to say. Not to change the resolution that it has. They have 2 heavy haulers named Otto and Lori, 28 wheels each. I'll show you those in a minute. And they can study a variety of things. Planetary systems, complex molecules, stars, galaxies, black hole regions, and so forth. So here we're entering the grounds, and there are a few rules. For a heavy vehicle, we can't go over 40 kilometers per hour. For a light vehicle, I guess our bus was light, so we can go up to 36 miles per hour. It's obligatory that we wear our seatbelts. Have to have the lights on. We got to pay attention to the security guards. So here's the entrance to the observatory grounds. And once we're through, we're driving up a fairly gentle slope. There's some wild horses or mules or something up there, and there's that volcanic peak again. And these are the buildings that house the facilities there. So we are just gathering together. Another T-shirt, right? This is our local guide here. Okay, this is Swirl Astronomy Club, same guy from Arizona. And you recognize the pattern of these stars? Yeah, this is the constellation of Scorpius. Say again? Is that where it is? It could well be. Saguaro National Parks are near Tucson. So here's our guide. And we go, so I took a picture here of the shadows on the deck. I thought it was kind of interesting. Now we're inside looking out of the windows, and the roads which go up to the location of the radial telescopes sort of goes off in this direction, and they're a few miles away from this location. No idea. Could be water. Inside the control room. And we encountered this individual who's a professor of astronomy from an American university who carries out research here. And he talked to us for a while. And I carefully wrote down his name and the university where he works. And then I lost a piece of paper. So now I don't remember his name or which university he is. Does anybody recognize him? Okay, I'll have to do that. So now we're going to take a tour outside, and we all have to wear these hard hats. And we're going to go out and see the heavy haulers, which are used to move the radial telescopes around. So here it is. There are two of them. They're each 20 meters long, 10 meters wide, and they weigh 130 tons each. And they move around the radial telescopes, which are 115 tons. And when it's loaded with a telescope, the maximum speed, 7 miles an hour. This is a pressurized cab. So this is where the driver sits. He's in a pressurized cabin. He's fed supplementary oxygen in there, so he doesn't pass out and run into a ditch or something on the way up. They don't like people dying. So there are 28 wheels altogether. So this is one of the dishes outside as an example. That's what they look like from the front. So this is not where we were, but this was taken up on the plateau where they're located. There's another picture, but this looks so neat and clean. I suspect this is a model, not an actual picture. Yeah, it's not that clean. There's other things like snowbanks and so forth on the ground occasionally. So anyway, this is a hauler with a telescope. So that's what the configuration looks like.
Is there a reason that there seems to be a concentration toward the center?
Yes, there is. Yeah, there are 16 of these radial telescopes concentrated towards the center, and that they use when they want to look at a wider region of the sky. When they want to narrow down and look at a smaller region, they use those and also the telescopes further out. That is a nice picture. You can see the sky there. And if you look carefully at the sky, you can see a fuzzy patch there and a fuzzy patch there. And those are the large and small Magellanic Clouds. I did not take that picture. No, I stole that from somebody. So these are the Magellanic Clouds, which are neighboring galaxies. They're part of the Milky Way system. They're gravitationally bound to the Milky Way. Okay, so that's now we're going to do 2 quick tours because we're through the telescopes. We're going to go to the highest geyser field in the world. So this is El Tashio. It's let's see, it covers about 4 square miles. It's comprised of geysers and hot springs, boiling mud pools, and fumaroles. There are more than 80 active geysers here. And we're at an altitude of 14,200 feet above sea level. So the air is noticeably thin. Even though we've been living for a couple of days in San Pedro de Atacama at 7,900 feet. So we're kind of used to high altitudes. But about 14,000 feet, we can definitely tell the difference. For some reason, it was important to get there before the sun came up. So we got up when it was very dark, drove up there, and got out and looked at the various geysers. These are all fairly short geysers, usually just a few feet high. The very highest is about 20 feet. So I didn't sample the water. I don't know. I suspect it's not very fresh water, but I don't know what might be dissolved in it. And so as the sun comes up, we can see a little bit more. This is very close.
For the source of the geysers, the spring, how you're at 14,000 feet.
That's right.
So
There are higher mountains all around us.
I know, but the source of the heat, the magma, wherever it is down below 14,000 feet down.
Yeah, I assume it is down below us and maybe around us and up in some of the higher.
If they're coming up, they've got to be pumped up. Old Faithful is, only a couple hundred feet, I think, above sea level, right?
Oh no, it's much higher than that.
Yeah, you're right.
Yeah.
I'm saying you're going to get that going up 200 feet because it's 6,000 feet lower than these are.
Yeah, how far did the water have to travel from the base?
That's what I'm asking.
There's a lot of way to come down, several miles long.
Well, I don't think it's coming up from way down thousands of feet. I think it's probably more or less local water. And there's heat coming up from the ground, from magma or whatever is down below. But the mountain's thousands of feet higher than we are standing here. So that'll provide enough pressure to push the water up in these geysers when they form. So we didn't have any breakfast before we drove up here. So after a while, they fed us a high altitude breakfast. So here we are munching on our sandwiches. And then afterwards, we take kind of a scenic route back to San Pedro. Some of the local animals. And a scenic canyon. And now we've gone to the Valley of the Moon, which is just 8 miles west of San Pedro. So there are rock and sand formations here which have been formed by wind and water. And again, this what you see is salt deposits. So this is our guide again, Kelly Beatty, and another one of his astronomical t-shirts. And he got an Nikon camera. Yeah, the white stuff is salt. What's that? 7,900 feet. So it's quite scenic. There's also a small cave or tunnel, which we went through. those of us who would fit. And these are people coming out of the other end of the tunnel. And then we flew back to Santiago. Got there around noon or so, and we all were taking evening flights, overnight flights back to the U.S. So the travel agency, the head of the travel, this was Spears Travel Agency, which arranged the trip. The head, Gary Spears, was there with us, and so he spent some of his own money. He hired a bus and said, instead of sitting around the airport for a few hours, let me take you somewhere interesting. And he brought us down to this vineyard where we spent a few hours walking around, much more pleasant than sitting in the airport. This is a special vineyard. It's an organic vineyard. They can grow their grapes without the use of pesticides or artificial fertilizers. And it's quite scenically laid out. And again, the most interesting part to people was the tasting room. And so what they provided us with were 4 different wines, 2 whites, 2 reds. And with each wine, they had selected a special cheese to go with the wine. And even though I don't like wine very much, it was overall quite pleasant. So here are the wines that we sampled. So after this, we went back to the airport. We flew home, and our tour was over. We all had a very enjoyable time. So thank you for your attention. That's the end of my talk.
Are you going back to Chile in July for the eclipse?
No, I'm not going back to July. I know we have a couple people here who are going.
How did the rovers pick up the telescopes?
Say again? How do they pick them up? That's a very good question. Well, we didn't see that happening, and I don't know the answer to that question. If you go to the website, Alma's website, you can probably somewhere get that information. I don't know the answer. Yes.
This tour was done through Sky and Telescope.
Yeah, Sky and Telescope arranged the tour.
Because I know a guy who arranges tours in Chile.
Yeah. Uh-huh. Yeah, well, the arrangements were made by Sky and Telescope and Spears Travel Agency out of Oklahoma. Yeah, I've been on a few tours through Spears Travel Agency. Went to Iceland once to see the Northern Lights, which didn't come out while we were there, and a couple other tours as well. So Sky and Telescope and Spears have worked together several times.
What group was it when you went to Antarctica?
When I went to Antarctica,
What was that?
to the South Pole, I went down there twice. South Pole, that was me. The company was ALE, Antarctic Logistics and Expeditions. It's the only company that has private facilities on the continent. Everything else on the continent are scientific research stations. ALE, you have to make arrangements with them separately and send them lots of money. Yes?
How did the guys get out of the heavy duty bowler? They can't breathe, so how did
Well, they can have oxygen tanks. So they can breathe supplementary oxygen when they're outside.
have to wear the oxygen tank?
I think people who work there frequently probably can survive without the oxygen.
Did you see any of those people?
Not where we were. We didn't go up to the high elevations. I mean, I know what 14,000 feet felt like, and I think we didn't want to go any higher than that. Yes?
There's about 30 to 40 peaks in Colorado.
Yeah, right. Yeah, Pikes Peak is one of them, which I've driven to the top of. My car didn't like it.
Pikes Peak is the tallest mountain in Colorado.
Say again?
Pikes Peak is the tallest mountain in Colorado.
It is the tallest.
It is not.
It is. Yeah, it may not be.
Mount Elsie is taller.
Okay. Yeah, but they're all under 14. They're all under 14,500. Yeah. No. No, Mount Whitney is the highest in the 48 states at 14,500. 14,500 is Mount Whitney.
Had a hard time coming back down.
No. 14.5 is the highest in the 49 states. Anything else?
Any other questions, guys?
You learned Spanish?
No, I did not. We had a translator whom you saw. Yeah, I probably learned a few words which I've forgotten. See? Yes, I know see. You know, buenos dias, buenas noches, buenas tardes, senor, senora, senorita. That's about it. Okay, well, thank you again.